Here's a vector diagram question. You have a rod, a beam, horizontally hinged at point Y, held stationary. Now this is kind of important because you know it's in equilibrium. But what are they asking us? The beam is supported, the forces are FC and FB. Okay, so this one is FC, and the force in the beam are FB. Which vector triangle represents the forces acting on point X? Now, a very important keyword is this, acting on point X. Because if you see like, well, there's so many stuff happening. What is point X? Where is point X? Imagine that X here is a dot, I guess. Okay, yeah, sure. So it's a dot. Imagine this. So the first thing you have is there's some weight of the dot. Because you see W is already pointed there. So I guess the weight somehow is acting on this. So we can draw a weight arrow like that. Then you have FC and FB. Now, which direction is FC and FB pointing to? Is it this way or is it the other way? How do we know? Well, we're thinking in perspective of the dot X, right? So what holds the X up? The cable. The cable have to pull it up. So if you're looking from the perspective of X, your cable will be pulling it up. This is FC. Okay, and the last one, the beam. Now, is the beam pushing X out or pulling in? You kind of think of this a little bit. Now, the thing's in equilibrium, right? So what if you go and draw FB this way? Hang on a second. Wouldn't be a net force to the right? Look at that. Because because there are arrows pointing to the right. So this X would be moving to the right. But no, we know it's stationary. So FB cannot be pointing to the right. In fact, FB will be pushing out something like this against the rod. So that now there is no net force. You got up and down, you got left and you got right. It's all cancelled out. We're good. So now you have to think of these things first. So let's look at, let's start with W. W should be pointed downwards. So we go through every single diagram and see where is W pointed downwards. This is good. This is wrong. This is good. This is wrong. So these two are out. Okay, then we look at FB. FB should be pointing to the left. So we look for everything pointing to the left. FB to the left, correct, wrong. C is out. That leaves us with A. But let's check FC. FC should be pointing to the top right. So we can once again go and see. This is correct, this is wrong, correct, and wrong. Okay, A is the answer. That is all three forces. You can form a closed triangle because this rod is in equilibrium, or this point is in equilibrium. It's not flying anywhere, so it forms a closed triangle. No resultant force. If you're not sure how to get that triangle, you can also do what we call rearranging tip to tail. So if I have these three forces, I can just grab them. I like this. And just rearrange them, something like this. And ta-da, you have a triangle. There, you found the answer. Now, it's kind of hard to do this on paper, I know. But this is one way where you can rearrange the forces tip to tail so that you can see the end product triangle, the vector triangle. Okay, so that is all for this question. Hopefully that was helpful in helping you think about vector diagrams. Any doubts, just comment below. But I'll see you in the next video. Next question.